So now let's try it. Graphing these exponential functions right here. We're using two different functions. We're going to use a shift or a translation of some sort here. So we're using our base, f of x equals 3 to the x. And that was the one that we graphed a couple of videos ago. What do we do with this kind of function? Well, in this case, all right, let's use this as our base. We know that if we go through -1, we're going to get 1/3. We know that if we go through 0, we would get 1. If we got 1, we would get 3. So what does this -2 do to the function? Well, if you recall from some time ago, whenever we had a function like g of x, and g of x was equal to -2 times whatever the original function f of x was, that did two things. The negative caused us to have a reflection about the x-axis, and the 2 would cause a vertical stretch. Well, what does that mean to us? Okay, the easiest way to handle this would be to say, well, all right, if I knew what 3 to the x does, then every single one of these points I can take whatever y value I'm getting and multiply it by -2. So let's take, for example, on 3 to the x, we have y equals 1/3 at x equals -1. So if we get -2 times 3 to the x, we're going to get y equals -2 times 1/3, which would be -2/3. Where we got y was equal to 1 at x equals 0. If we take -2 times the y value there, we get y equals -2. And if we take -2 times y equals 3, I'm sorry, y equals 3, talking and writing at the same time. Watch it, Professor Peoples. Y would normally equal 3 when x is equal to 1. In this case, y would have to equal -2 times 3, that's -6. So graphing our function now, we get y is equal to -2/3, about 2/3 of the way down right here. At -1, we get y equals -2 at x equals 0, and we would get y is equal to -6 at x equals 1. And so our function, follow this pattern, pass through the y-axis here at 0, -2, and then continue down towards -infinity. There would be a horizontal asymptote in this case, still at y equals 0. We would have our y-intercept at 0, -2, and you'll notice, by the way, that's the value that we get when we're multiplying 3 to the x by something. And then we would have another point down here that we could find at 1, -6. And really, those are very simple points to get by multiplying our y values by -2 in each case. So now let's take a look at h of x. What's happening here? Well, now these are two horizontal and vertical translations, right? We would have said earlier, if we had f of x, and we took h of x and treated it as f of x minus 3, that is, replace x everywhere we see it with the quantity x minus 3 plus 2, we would know that that would mean to take our original graph, shift right by 3, and shift up by 2. So let's do that right here. We've got our original graph over here. We know that we would normally pass through -1, 1/3, 0, 1, and 1/3. Let's start with this point right here and do a shift. If we were to go to the right by 3 and up by 2, instead of passing through 0, 1, it would pass through 1, 2, 3, so 0, 3, 3, 1, and then up 2, it would pass through 3, 3. And again, a way to picture this is to see this as a shift, right 3, up 2. All right, let's take our other points here. We know that instead of passing through negative 1 1/3, we'd have to go to the right 3, so that's 2 to the right. So we'd have negative 1 1/3, so we'd be at 2 1/3, and then up 2, so 1 2 right here. Well, we need to do a little bit of math right here. 2 plus 1/3 is the same thing as 6/3 plus 1/3, so we would say 7/3 right here, and so we know this graph would pass to the point 2, comma 7/3 now with that shift. Finally, our point 1 3, remember we're shifting to the right 3 and up 2. So if we went to the right 3, that means we would start at 1 3, and we would come to the right 1 2 3 to 4, and then go up 2 here. And you can see that right 3 from 1 gives us 4, and up 2 from y equals 3 gives us 5. So we're doing pretty good. Now one more thing. Remember that we have a horizontal asymptote at y equals 0, right? But because we have that shift up 2, every feature of the graph also changes up 2. And so we would dash in our horizontal asymptote now shifted upward by 2. There's our horizontal asymptote. And our graph would follow along this horizontal asymptote through the 3 points. And as we go to the right, y would tend towards infinity. And that's our sketch now of h of x equals 3 to the x minus 4 plus 2 with our shifts all attached.